This project uses an SN754410 to control the speed and direction of a DC motor. An ATmega 328P MCU on an Arduino Uno is the central control unit. A keypad is used to speed up or slow down the motor, change its direction, and cause it to start or stop. An OLED display is used to show the relative speed of the motor as a 1-byte value, the status of the motor's 2 pins as either high or low, and whether the motor is on or off based on whether it has any voltage potential across its leads. A DC motor works by an electromagnet which produces a magnetic field when voltage and current is put across it, spinning inside of a permanent magnet. As they repel each other, the electromagnet spins itself in the attached motor shaft, producing torque. The direction of the torque can be changed by inverting the supply on the 2 motor pins connected to the electromagnet, meaning the high pin becomes low and the low pin becomes high. The speed and direction control of the motor is done with the SN754410 H-Bridge motor driver IC. An H-bridge features 4 electrically controlled switches, such as transistors. When 2 of the switches are activated, meaning current can flow through them, the motor spins one direction. If those 2 switches are deactivated and the other 2 activated, then the motor's direction changes. Snubber diodes are used to allow current to flow across the motor, even when the H-bridge switches are not open, protecting them from when the motor is suddenly turned off. When the motor is running, the diodes do not affect it, as they are arranged in the reverse direction of current flow. The control IC is connected to the MCU as shown. The motor is connected across the 2 motor terminal pins. The supply voltage for the motor comes from a dedicated 9-volt battery via pin 8. The rest of the circuit operates off of a second 9-volt battery, regulated down to 5 volts. The motor can be turned on by putting a high on one motor logic pin and a low on the other with the MCU's digital outputs. The direction is controlled by inverting the state of those pins. The speed of the motor is controlled by a PWM signal on the enable pin. PWM works by changing the duty cycle of a square wave signal, emulating an analog voltage level. The signal switches between being at full voltage and ground. The varying duty cycle simulates a voltage from 0 to 5 volts. The higher the simulated voltage on the enable pin of the motor driver IC, the faster the motor spins. The code on the MCU takes the input from the keypad and responds by either increasing or decreasing the voltage from the PWM signal, changing the motor's speed, inverting the state of the logic pins, changing the direction of the motor's rotation, or pulling both logic pins low, stopping the motor. All of this information is displayed on the I2C OLED display.